Hello, we are the Markforged 3D Printing Material Test Group, and this presentation is given to you by Remington, Luke, Tim, Tyler, Basil, Jacob, and Maya.
The purpose of the 3D printing material test is to verify Markforged's claims that their Onyx material exhibits properties similar to 6000 and 7000 series aluminum. This material is an engineered nylon. To demonstrate the strength properties of 3D printed nylon and carbon fiber reinforcement, the group planned to print test pieces using these materials on a Markforged Mark II desktop 3D printer, then follow the already established physical testing methods selected by Markforged.
Markforged has given us a template for the tensile decompression and the flexural tests. We have also designed 2 tensile tests, another compression, and 1 more flex test to get different shapes and sizes during our testing. We'll be printing 6 different batches of our test pieces. Each test piece will be maximized in infill and with maximized carbon fiber. We will be using a randomized test batches to get rid of inconsistencies in printing. As a group, we wanted to be able to understand the unidirectional forces in the carbon fibered printing. So we wanted to be able to test pieces that were made on the flat face and on their sides, so we could see the differences in the amount of load we could take on each piece.
The main costs associated with this project were printing materials. We partnered with Advantage Litho to get our printing supplies at a discount. The test pieces we created were made from carbon fiber and onyx. These cost $411 and $140 per spool, respectively. We also ordered 7075 aluminum to create test pieces to compare to our 3D printed pieces. This comes out to $621. However, we were only able to utilize $311.74 of our material in our limited time for testing.
For our testing methods, we'll be running 3 different tests: a tensile test, a compression test, and a 3-point bending test. The tensile test is as shown. A compression test is when you remove the gripper fixtures and have a custom fixture that closes on either side. And the 3-point bending is 3 anvils with 1 stationary and 2 moving anvils. We'll also be testing 7000 series aluminum with 6 dog bone shapes, and we have 6 pieces for each test, with 1 printed on their flat side and 1 on the side. And we can't use IZOD or the heat deflection because they're too old. For engineering standards used are D3039, which is plastic and composite tensile testing, D790, which is 3-point flexing, D6641, which is compression of composites and plastics, and E816AE, which is tensile test of all metals or sheet metal.
From an engineering standpoint, we ran an FEA simulation on the carbon fiber reinforced onyx material on SolidWorks to provide a foundation of supplemental information on the possible results we could obtain from our material testing. We chose to run a linear static versus nonlinear simulation on the carbon fiber. This was decided due to the fact that carbon fiber is a very linear material that exhibits a minimal stress strain curve before its breaking point. This decision was also made by the fact that you must provide supplemental stress strain curve for a material if it is not in a software material library. Since we could not find a software that was available to us with this information, we just had to go with a manual input of the material properties provided by Markforged and do a linear simulation. We were able to hand calculate the forces required to break the pieces based on the material properties and cross-sectional area of the test pieces. After we applied these forces, we ran a tensile and compressive simulation on the carbon fiber and found an average error of 17.62% between the simulation and the values provided by Markforged. The 2 categories we compared were tensile strain percentage at break and compressive strain percentage at break. By the conclusion of this project, there should be a definitive answer as to the strength comparison of this 3D printed material and 6000 to 7000 series aluminum.